Hey everybody, this is the second video about trig. We're going to kind of get away from the unit circle and just simplify trig expressions. So a couple things you'll probably want handy, these trig identities and Pythagorean identities handy when you're doing these types of problems if you're not like used to them. So remember, in the other video, cosecant is 1 over sine. Secant is 1 over cosine. You don't really need this cotangent is 1 over tan. I would definitely do cotangent is cosine over sine. Tangent is sine over cosine. Okay, and then we also have these Pythagorean identities. Cosine squared plus sine squared equals 1. And 1 plus tan squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. These Pythagorean identities you get from the unit circle and the Pythagorean theorem. If you are dying to know how to find or how we get these, I can show you, but at a later time. All right, so I've got an example already laid out for you with everything written out. So first, you're going to be asked to simplify the trig expression cosecant theta tan theta. Remember, theta is just that Greek letter that represents a variable. So if you see an x instead of like a theta or that Greek letter, it's the same thing. So it just means the angle. So don't freak out or whatever when you see it, because it'll be there all the time. So simplifying. Cosecant theta tan theta. So I'm going to rewrite cosecant as 1 over sine, and then they do it in the next step, but they simplify or rewrite tan as sine over cosine. Okay, so and then what they end up doing is they end up multiplying on top. 1 times sine is sine, and then on bottom, sine times cosine is just sine times cosine. Well, they simplified here. They ended up canceling out sine over sine. Okay, that just becomes 1, or 1 over cosine would be left, or 1 over cosine simplifies to be secant. So basically what you're trying to do is if you have like something with like 2 trig functions, you basically want to try to get it down to 1 trig function. Okay, so I've got several examples here. So sine theta cosecant. So sine, that doesn't change, so that's still going to be sine theta. Cosecant, remember, is 1 over sine theta. Now, if you want to put that sine theta over 1, you can do that, and then multiply across. So sine times 1 is sine, 1 times sine is sine. Okay, nice and easy. This cancels all out, and that ends up being 1. Okay, simple, hopefully enough. So we've got the next example here, tan theta cotangent. So tan, remember, is sine over cosine, and cotangent is cosine over sine. Okay, if you want to multiply across, so sine theta cosine theta, and then multiply across on bottom, cosine theta sine theta. Well, I notice here I've got a sine and a sine, a cosine and a cosine, all be canceled out, and we have our answer to be 1. Okay. Let's keep going. I've got secant here times cotangent. Secant is 1 over cosine. Cotangent is cosine over sine. Okay, so multiply across the top. 1 times cosine is cosine, and then cosine times sine is cosine sine. Again, the cosines can cancel out, and I'm left with 1 over sine. I know this might be like, oh, I'm done, but not quite. You want to, I don't want this fraction here. I don't want that to be 1 over sine. So that's 1 over sine is the cosecant. So that would be my answer. Ooh, now I've got 3 trig functions. So I've got sine, theta. Secant is 1 over cosine again. And then cotangent is cosine over sine. Okay, and some of these you can kind of already tell that things are going to cancel out, like the cosines here and the sines. So the more practice you do, and the less you'll probably end up having to show like all of this work and kind of get used to doing stuff like this. So that simplifies to be 1. Okay, kind of nice. All right, here we go. So secant theta, cosine theta, sine theta. So secant, I just got to simplify. It's just 1 over cosine theta. Cosine is cosine. Now, if you want to put it over 1, you can. And then we have sine over 1. Again, cosines are going to cancel out. And then we're basically just going to be left with sine theta, right? 1 times sine is sine, 1 times 1 is 1, and that would be my answer. Just sine over 1 or just sine. All right, cosecant theta, cosine theta, and tan theta. Cosecant is 1 over sine. Cosine is just cosine over 1, and then tan is sine over cosine. Kind of like the similar problem from the other slide. Things are going to cancel out. I forgot my thetas. Things are going to cancel out. Cosine and cosine, sine and sine, and you're just going to be left with 1. Okay? All right, I got several more examples here. Now, these two, we're going to get into the Pythagorean identities. So basically, I want to see like which ones do they kind of resemble? Do they have similar trig functions? So like this first one here, I have 1 minus cosine squared. So, well, I know that Pythagorean identity we talked about was cosine squared theta plus sine squared theta equals 1. Okay, now if I can make like this to look like that, or the other way around, maybe if I can make this Pythagorean identity look like that, then I'd be able to find my answers here. So I have 1 minus cosine squared. So I'm going to subtract cosine squared on both sides. Okay, so this cosine squared cancels out. So I've got sine squared theta equals to 1 minus cosine squared theta. Well, see how it looks the same? So that means this is going to be, the answer would be sine squared theta. Okay, now I know it's weird to see the squared like right next to the sine, and just treat it like an x squared, okay? It means the same exact thing. It's sine times sine, or x times x, right, is x squared. So sine times sine is sine squared. All right, so secant squared minus 1. So if I go back to these the Pythagorean identities, I'm looking for secant squared. So I see that's that middle one right here. So if I've got 1 plus excuse me, tan squared theta equals secant squared. Okay, and remember, I'm trying to make it look like this, the secant squared minus 1. So I got secant squared over here. Well, if I subtract 1, then I'd be left with tan squared theta equals secant squared theta minus 1. So, and then there's my answer right here, tan squared theta. Okay. Next one here. Okay, secant squared minus tan squared. Same thing. So if I'm looking at that one Pythagorean identity, 1 plus tan squared theta equals secant squared theta. Okay, so if I were to, basically, I got secant squared minus tan squared. So if I subtract tan squared from both sides, I would be left with, well, 1 would be left on the left side. I'd have secant squared theta minus tan squared theta on the right side. So 1 would be my answer here. Okay. Now this example over here, I have a sign squared, but notice I don't have any like addition signs or subtraction signs. So that means I'm not going to be using this, any of these Pythagorean identities. I'm going to kind of go back to the way that we were, like some of these other problems where we just had to simplify. Okay, so that's sine squared. All that means is you've got two signs there. So if you want to write them both out, you can. So if you want to write out sine theta times sine theta times, well, cosecant is 1 over sine, and then the secant is 1 over cosine. Okay, then all on bottom here we have tan, which is sine over cosine. All right, I'm going to kind of clean up the top here. So I see I have a sine on bottom and a sine on top, so I'm going to cross those out. So remember, these are over 1. So I will have a sine on top and a cosine on bottom. That's all in the numerator here. Okay, that's all in the simplified numerator. In the denominator, I'll have sine theta over cosine theta. Okay, so notice my numerator and the denominator are the exact same. So that's going to all simplify to be 1. Okay, I've got one more example here. All right, I've got sine over cosecant plus cosine over secant. Now, this doesn't look like a Pythagorean identity yet, so I can't really do anything with these identities. So I'm going to try to rewrite them or simplify them, like the cosecant and the secant. I'm going to simplify and see if maybe it'll turn into an identity. I don't know. We'll see. So I've got sine over cosecant. So sine over 1 over sine plus cosine over the secant. Again, that's 1 over cosine. Okay, so I'm going to simplify these fractions kind of separately. Remember, when you have like a fraction within a fraction, you keep change flip or keep change reciprocal. So sine theta times sine theta over 1. Well, sine times sine, like we talked about here, would be like sine squared. So this is sine squared theta. Same thing over here, keep change flip, cosine theta times cosine theta over 1, or cosine times cosine is cosine squared theta. So now I see I've got sine squared plus cosine squared. I'm going to go back to these identities. Ooh, I see Pythagorean identity, cosine squared plus sine squared equals 1, or sine squared plus cosine squared, it's going to equal 1. And that would be my answer. All right, if you have any questions with any of this stuff, or if you need like a video conference with Mr. Mangold or myself, please don't hesitate to reach out to either of us. I know this is kind of a weird time. Please don't hesitate to ask. All right, enjoy.